Okay. Well, good morning, everyone. Just give me a second here, please. Okay. I think we started with the energy and ecosystem here. The last lecture, as a matter of fact, well, yeah, okay, just, I may wait, I don't know, maybe. Yeah, last lecture we started basically with the energy and ecosystem, and then we talk a little bit about the nature of energy, and in this one, basically, we talk about the electromagnetic, kinetic, and potential energy. We talk a little bit about electromagnetic energy, okay? And then the other point, we talk about the kinetic energy, and I think from there we're going to continue. So the last subtopic I talked about was under the kinetic energy. Okay. And, okay. And already, I think I mentioned to you in this regard one line, I'm going to repeat it again. The kinetic energy is associated with motion. Already I mentioned that is associated with motion. And we can distinguish two classes of kinetic energy. We mentioned there are about two classes of kinetic energy. Okay. And I think the first one mentioned to you here is basically mechanical kinetic energy. Okay, and we're going to talk about this one here. Now, mechanical kinetic energy is associated with objects in motion. Is associated, okay, is associated with objects in motion. Okay. For example, as already just give you an example. For example, a baseball flying through the air. For example, okay, a baseball, okay, flying through the air, okay, or for example, another like deer running in a forest. In a forest, or also to mention, for example, water. Okay, flowing. Okay, in a stream. Okay. Or even like, for example, like also like a planet also moving through a space. Do you see this clearly, please? Okay, just to make sure. Okay. Now, basically, sometime we can, I don't know, yeah, okay. Now, of course, to mention the other point, the amount of mechanical kinetic is determined. The amount, okay, of mechanical kinetic, okay, is determined okay, by the mass of an object, this is one part here, and also, and its speed, this is the other thing. Now, then as you mentioned, basically there are kinetic energy two types. One we mentioned basically as a mechanical, the other one here known as thermal kinetic energy. Thermal kinetic energy, simply to mention, is associated with the rate of vibration, with the rate, okay, of vibration, with the rate of vibration of atoms or molecules. Or molecules. Now, usually, as I mentioned, such vibration are frozen at absolute zero. Such vibration okay, are frozen at absolute zero, which is simply basically is to the physical thing is which is equal to minus 273 degrees Celsius. Okay. But of course, to mention, but they are progressively more vigorous okay, more vigorous, basically at higher temperatures. At higher temperature, or temperatures. Okay. Basically, as I mentioned, corresponding okay to a larger okay content of thermal kinetic energy. Okay. And simply to mention, of course, that in this regard, that thermal energy is sometimes also referred to as heat. And to mention this point here, thermal energy okay, as heat. Okay, and just here's the machine here. Okay, so basically by this, basically I will have this review about what you call the kinetic energy. Now going to move to the third type of energy you mentioned, because you mentioned electromagnetic, kinetic. Now going to move to the potential energy. Okay. And of course, potential energy simply it is what you call, like if we can visualize it like this one here. Just give me a second. Okay. That's some type of potential energy over, okay? That means there is an energy for a work here to mention to you this one here, okay? So that's we mentioned this point that potential energy, okay? It is the stored okay, it is the stored ability, okay, to perform work. Is the stored ability to perform work, and to actually perform work okay, potential energy okay must be transformed okay must be transformed into electromagnetic or kinetic energy. Okay. And also to mention, of course, there are various types of potential energy. there are various types of potential energy. Okay. Basically, there are gravitational one, chemical one, I'm going to talk about it, and also electrical and so on, to mention to you here now. Gravitational potential energy. Sorry. Gravitational potential energy, which is basically, of course, result from the attractive forces between objects. Results from, okay, called attractive forces, okay, between objects. That simply it means gravity, for example, gravity. Okay. Now, to give you an example of this, for example, water is stored at high. Okay, for example, water, okay, is stored at any height above sea level, okay, contain gravitational potential energy. For example, okay, water stored at any height above sea level contains gravitational potential energy, okay, and of course this can be converted, as already you know, and this can be converted okay into kinetic energy. Okay, if a pathway allows the water, if a pathway, okay, allows the water, okay, to flow, okay, downhill, to flow downhills, and also okay, and also can be converted into electrical energy, okay, into electrical energy, okay, through technology, okay, let's continue here. one? Okay. Through the technology, as a matter of fact, of hydroelectric power plant. Technology through, okay, hydroelectric power plant. Okay. So basically, this is what we talk about, that what you call gravitational potential energy. Then also we have what is known as chemical potential energy as part of the potential energy. Also, we have chemical potential energy. Okay. And basically, this one, of course, is stored in the bonds between the molecules. To mention, it is stored in the bonds between atoms within the molecules. To mention this one, okay, it is stored okay in the bonds in the bonds between atoms within molecules. Okay, within molecules. And also to talk about that chemical potential energy, chemical potential energy, okay, can be liberated okay, by exothermic reaction known as exothermic reactions, okay. That means what it means basically those, okay, which lead, okay, to a net release of thermal energy. Okay. As for example, as for example, when, just to mention, for example, chemical potential energy, okay, is stored, okay, in the molecular bonds, okay, of sulfide minerals. Okay, such as, for example, mentioned to you here, such as iron sulfide. Okay, which is simply basically as FeS2. Okay, Also the same thing, for example, if you take some salt and dissolve it in the table salt to take it in water, basically also there are some kind of heat is released, to mention this point. Also, to mention this point here, another example, I think you finish from this one and just put it back here. Okay. Also the ionic bond of salts. Of salts, okay. For example, when say table salt, okay, which is sodium chloride, okay, is dissolved, okay, in water, all right. Ionic potential energy called ionic potential energy is released as heat. Okay, is released as heat. Then also we have the third form of this one, which is known as electrical potential energy. Okay. And this one basically to mention, it result or results, to mention this one, it results, okay, from differences in the quantity of electrons. And the quantity of electrons, okay. And to mention, for example, that electrons which are subatomic negatively charged, okay, electrons, okay, which are, okay, called subatomic, negatively charged particles, okay, a flow from areas, okay, of high density, okay, to the area of lower density. Okay. And that's why basically we'll mention here, for example, when electrical switch, okay, when electrical switch is used to complete a circuit, basically connecting two areas, okay, with different electrical potential. Okay, potential. Electrons flow along electron gradient. Electrons flow, okay, along electron gradients, okay, and in this case, of course, that the electric energy okay, may then be transformed okay, into light. Light, heat, or work performed by a machine. Okay. Now, the other thing to mention also that compressed gases okay, also store okay, potential energy. Potential energy, which can do okay, work which can do work, of course, when the gases are allowed to escape. Oh, sorry, to expand. Okay. Then also we have the other form basically of what you call of this potential energy, which is basically known, okay, known as nuclear potential energy. Okay. And this is basically the nuclear potential energy to mention. It results okay, from extremely strong binding. It results from extremely called strong binding forces, or strong binding forces that exist within atoms. Okay. And to mention this, of course, this is by far what you call the dense, okay? This is by far, okay, which is, we call it from the densiest, okay, form of energy. Okay. And to mention, okay, because what happened here, that a huge quantity, okay, a huge quantity of electromagnetic and kinetic energy, a huge quantity of electromagnetic and kinetic energy okay, are liberated okay, are liberated when a nuclear reaction okay, when a nuclear reaction, as a matter of fact, reactions convert okay, convert matters into energy. Okay. And to mention in this regard, of course, what's going to happen here, that fission reactions okay, fission reactions involve okay, I think I put them here. Okay. And this is E here, involve, as a matter of fact, involve simply, okay, do you see this one here? Okay, involve, as a matter of fact, what you call the splitting of isotope. Involve the splitting of isotopes, okay, of certain heavy atoms. Of certain heavy atoms, okay, such as, for example, uranium, okay, 235, okay, and also, and the other one, and also plutonium, which is by plutonium 239. Okay, basically these to generate okay, to generate, as a matter of fact, smaller atoms okay, generate smaller atoms okay, plus enormous amount, of course, of energy. of energy, okay? And as already you know, for example, that fission reactions okay, that fission reactions, what you call, occur, okay, in a nuclear explosion, okay, and also to mention, and under controlled condition. Conditions in nuclear reactors, in nuclear reactors, which is simply used to generate electricity. Okay, this one here. Let's finish this one. Okay. And also we have other kind of reaction known as effusion reaction. Okay, the fusion reactions, okay, also occur in a type of a nuclear explosion, of a nuclear explosive, okay, device known as hydrogen bomb. Usually sometimes the technology has not reached so far yet, okay? In which to mention a technology has not yet been developed, okay, to exploit what you call control fusion. Called control fusion reaction. Simply to mention, of course, in this case, that if this able to be achieved, of course, can produce in reality unlimited amount of electricity. To mention to you this one here, okay? And so if and when if and when available, okay, controlled fusion, okay, could be used to generate, okay, virtually We call unlimited amount of electricity. Amount of electricity. Okay. So basically, this is the form or the type we talk about of the potential energy. We have the gravitational, chemical, electrical, and also nuclear. We talk about it here and also explain this one. Now, basically, we're going to about, of course, about what you call the unit. Usually, the energy unit being used to explain it. You may know it, but at least talk about it here. Okay. Small subtitle here: that energy units. Okay. Simply we call the SI. Okay. Simply from French. No. Système. Okay. International. Okay. We call here the units. Okay. Which is simply, it means the international, okay, accepted system for scientific unit. The internationally accepted, okay, system, okay, for scientific unit. For scientific units, okay. Basically they recommended unit. The recommended unit is basically is the joule. Okay. So basically, what is the joule? A joule is defined is defined as the energy required, okay, to accelerate one kilogram of mass, okay, at 1 meters per square second here. Okay. That means basically that 1 meter per second. Okay. Okay. That means 1 meter per second. Okay. To explain this, for a distance of 1 meter. Okay. Of 1 meter. Okay. Now we're going to talk about basically the Earth and the energy flow in the Earth, because that's basically all this later on give us a background for now. Now, in the Earth, of course, we're going to talk about here, okay? And simply about, basically about the energy flow. Okay? To mention energy flow simply through the system. Energy flow through system. Now, to talk about this one. Of course, basically all that energy mainly it came from the solar energy in reality. So to mention this, solar electromagnetic radiation, solar electromagnetic radiation, okay, is by far, okay, the major input of energy, okay, that drives Earth's ecosystems. Okay, ecosystem. Now, to talk some about of this energy, as a matter of fact, some of the form, we cannot mention everything here at the moment, so we took some of it actually. Now, okay, Earth ecosystems, okay. So to mention this point here, that solar energy heats, of course, as you know, solar energy, okay, heat the planets, okay, one thing here, circulate its atmosphere, okay, atmospheres and oceans, also evaporate its water, okay, evaporate its water, and also and sustain, okay, sustain water basically, and sustains almost, okay, all its ecological productivity. Okay. Now, of course, if you were to basically most of it is in the end, all this energy in one way or another is radiated also back. Okay, to going to mention that basically all the solar energy, which is basically of the Earth, in one way or other it comes in one way or another, it's radiated back. So we're going to talk about this in a little bit summarized way here. Okay, to mention to you this point here now. Okay. Eventually, all solar energy absorbed by Earth, to mention this point here, eventually, okay, all solar energy absorbed, this is all solar energy absorbed by Earth, okay, is re-radiated. Is re-radiated okay, is re-radiated back to space. Okay, back to space in the form, okay, in the form of basically of electromagnetic radiation, in the form, okay, of and continue here, electromagnetic radiation, okay, of long or of a longer, okay, wavelength. Okay, do you see this one? Longer wavelength. Longer wavelength that was originally absorbed, okay, of a longer wavelength that was originally absorbed. Absorbed. Okay. Okay, so in reality, by this, we're going to mention, of course, what happened here. Basically, the Earth basically tried to maintain a perfect balance between what you call the input and output, to mention this point here. Okay, just to continue with this one. Okay, now, therefore, Earth okay, maintain, okay, a virtually, sorry, okay, I'm going to continue here. All right, this is clear for virtually, as a matter of fact, a perfect balance okay, between these inputs, okay, and outputs of electromagnetic energy. Okay, of input and output of electromagnetic energy So simply to mention this one here, so basically, okay, so in other words, okay, in other words, Earth okay, Earth is called a flow, okay, through, okay, system with an input, okay, input of solar energy. Now, whereas the energy is coming from the sun, called the solar energy, as you know, okay, and also an output, okay, of radiated energy. Take this, I think I'm finished on this one now. Okay, and re-radiated energy, and also no net storage of energy, to mention this one here. And of course, and no net storage of energy. And I think this should be clear, I guess. Huh? And in other words, basically, as a matter of fact here, in reality, of course, the Earth, as a matter of fact, all the ecosystem is totally dependent on that solar radiation in one way or another. Okay? And to mention this point here, okay, in addition, okay, in addition, Earth's ecosystems, that the Earth ecosystems absolutely depend okay, it depends on solar, okay, on solar radiation, okay, as the source, okay, of energy, okay. Energy, of course, basically what happened, that photosynthetic organism as you know, such as the green plant, all these, okay, utilize to synthesize okay, the simple organic such as sugar, okay, of course, as you know, from inorganic molecule. Molecules, which is, as you know, carbon dioxide and water. Okay. Because in reality, if you look at it in this way, that all our energy we use at the moment, whether it is coal, whether it is petrol, what is gas, or whatever it is, okay? In reality, all of it originated from that photosynthesis mechanism, okay? Because these photosynthesis organism, basically once they take that solar energy and they put it in as a mass in this plant, either you use the wood to burn it, which release the energy, or of course, as you know, all the natural gas or coal, or basically they are all fossilized plant and so on. So basically, these are what already to mention this point. Okay, so basically everything comes from there. So then we're going to continue subtitle. I guess it should be clear now. Can you see this one here? Then to Earth and energy budget. Okay. Subtitle here, Earth's we called it energy budget. Okay. Now, usually to define what it is here now, an energy budget. Okay, an energy budget, simply as a matter of fact, of a system. Okay, describes, okay, simply the rates of energy input, okay, and output. This is one thing here, but also at the same time, okay, as well as, okay, any internal as well as any internal transformation any internal transformation among its various states, and as okay, as well as any internal transformations among, okay, its various, okay, states, okay, including, okay, changes, including changes, okay, in stored quantities. Okay. Now, to make this point here, even though, as already we talked about here, now, even though the quantity of energy okay, the quantity of energy emitted by Earth, okay, eventually equals, okay, eventually equals the amount of solar radiation okay, the amount of solar radiation okay, that is absorbed, okay, by many, okay, ecological units, okay. Now, to mention here, low absorb, but at the same time also to mention that important transformation occur, also mention important transformation, okay, or transformations occur, of course, between, okay, the initial absorption okay, and eventual re-radiation. And eventual re-radiation, okay, and eventual re-radiation, okay. Now, to mention, these are, okay, these are the internal elements okay, internal elements of the planets, okay, of the planets, physical energy budget, physical energy budget, okay, okay, the internal limit of the physical energy budget that are described here below. How to describe this budget, okay, that described below. I'm going to mention this one here. We have basically a reflection in form of, just give a second here. Okay, reflection. Now, we're going to talk about different factors of this. By the time we absorb and then re-radiate, but during that time, so many things occur. Now, reflection, intimation. On average, Earth's atmosphere and surface, on average, okay, Earth's atmosphere and surface, okay, reflect about 30% of incoming solar energy. Reflect, okay, about 30% here, okay, just percent of the incoming, okay, solar energy, of the solar energy, okay. This is back to outer space. to outer space. Okay, now, are you following this here? Yeah, just a second here. Okay. Then also we have the other factor. Are you following this? Okay. Then we have the other one here. Absorption by the atmosphere. Absorption by the atmosphere. Okay. And this one basically to mention about 25% of incident solar radiation. We call it of incident solar radiation, okay, is absorbed, okay, is absorbed simply by gases, okay, vapors, and also what you call and the particulates in the atmosphere. Sorry. Of course, that also including clouds. Okay. Now, of course, going to mention, just have a couple of minutes to try to finish this few lines and then I will end my lecture. To mention basically what you call, now, that rate of absorption basically we call it looks like wavelength, basically specific to mention. I think you finished from this one, I put it down here. Okay, you can see this one here now. The rate of absorption, the rate of absorption, okay, the rate of absorption we call is wavelength, okay, it is wavelength dash here specific, okay, with portions okay of the infra range called infrared range being okay intensively absorbed, basically by the so-called green okay, absorbed, known as the greenhouse gases, absorbed by the so-called okay, a greenhouse gases. Okay. Of course, but the most important of these is the water vapor and the carbon dioxide. And I think also we have methane and other, but these are the two most important. I could mention between two brackets, especially. Okay, as I mentioned, water vapor and of course, and carbon dioxide. Okay. And of course, what happened here, because that energy or that soil which is absorbed, of course, is going to be converted into heat. Just give me 1 second, just to finish these two lines, to mention this point. The absorbed, okay, the absorbed energy is converted, in this case, okay, is converted to heat. And when it converts to heat, of course, it's going to be re-radiated as an infrared radiation. And in this case, what is going to be, of course, the infrared is a longer wavelength. And that's basically we mentioned to you. The absorbed energy is converted, what you call, to heat and re-radiated. Okay, and re-radiated as infrared. Okay, radiation, okay, of a longer, okay, wavelength, of a longer wavelength. And that's when I mentioned when there is a difference in the wavelength of basically of the one being absorbed and the one is re-radiated. Okay, did you follow this? Okay, because I think now I will stop my lecture here. I will continue, of course, later I'm going to use the other factor, which is the absorption by the surfaces and evaporation and so on. We could talk about it. Okay? Do you have any question, please? Let me know. Everything's okay? All right.
Yes.
Okay, that's good. Okay. Okay, then basically, okay, talk to you, I guess, on Friday. Okay, take care. Thank you for, all right, bye-bye.
Have a good day. Bye. Thank you.
You're welcome, bye-bye.